this here is actually the equation of a straight line, but it's in a different format. So if you were good at algebra, you could make y the subject of the formula. So you'd go 4y equals 12 minus 3x. So you've actually taken the 3x to the other side, and then you'd go y equals 12 minus 3x over 4, and then you'd have y equals 12 divided by 4 is 3 minus 0.75x. And then you would rewrite that as y equals mx plus c. So y equals mx plus c would be y equals negative 0.75 or 3/4. It doesn't matter. The 3/4 is probably easier for a gradient. X plus 3. However, that's not how we do it. We tend to instead find the x-intercept and find the y-intercept. So what value does y have on your x-intercept? So the x-intercept is any point on the x-axis. So any point actually has an x value and a y value of 0. Does that make sense? So if we let y equals 0, so we're going to go 3x equals 3x plus 4 times 0, because we were letting y equal 0, equals, anyone? 3x plus 4 times 0 equals 12. So then we get 3x equals 12. So then we get x equals 4. Okay? So when y equals 0, x equals 4. So that's the point 4, 0. 4, 0 is there. Now I'm going to, that's called my x-intercept, I'm going to let x equal 0. So I'm going to see what's the value of y when x is 0. So I'm going to go 3 times 0 plus 4y equals 12. So we've got 4y equals 12, so y equals 3. So what's my point? X is 0, y is 3. So the point is there. So the line, now I wonder if I can draw one. Oops, not quite right there. I might be able to move it. Oh, I can. There we go. There's my line. Okay? So the way that I drew something in this format, I need to get the right colour. The way I drew something in that format was to find the x-intercept and the y-intercept and join them. Now if we look at this, can you see that I could go 4 this way and 3 that way? So that gradient is actually negative 3/4 because the little skiing man would be going downhill. Okay, the plus 3 gives me the y-intercept of the 3. So there's 2 ways of doing it. Hands up who'd like another one like that. Yeah? Okay. So first I'm going to draw that one here. So it was, let's have a look. It was 3x plus 4y equals 12. 3x plus 4y equals 12. Okay, so there was our line. Nice. So we need to do another one. Back into paint. Alrighty, I'm going to do, let's make one up. 3x plus 2y equals 6. Okay? Right. So what are we going to do first? When x equals 0, what does y equal? When x equals 0, this disappears, so y equals 2 times what is 6? 3. Okay, when y equals 0, then this one here disappears because 2 times 0 is 0. So what do we get? X equals 2. So what are my points? Here I've got 0, 3, and here I've got 2, 0. So x is 0, 3 and 2, 0, and it's going to go through there. So let's try it. 3x plus 2y equals 6. 3x plus 2y equals 6. There we go. Okay? So we've learned a new trick. Did you want to do another one? So firstly, I'm just going to give you a bit of a reminder of ones we have done that will be in the test. And that's if I go x equals 3, I get a vertical line. X equals 7, vertical line. Y equals 3, horizontal line. Y equals -4, horizontal line. So those will be in the test. We have actually done those. Now the next thing is, what does an intersection mean between two things? So I'm just going to get a new one. Okay, so this case here, we've actually got the meaning of gradient in distance time graph. Gradient's actually speed. So what the key idea I want you to get today is, the steeper the line, the faster you're going. Okay? Now, in different contexts, that can be different things. So, for example, if it was to do with cost, if you had time on the x-axis and cost on the y-axis, the steeper the line would be the more expensive hourly rate. So think of slope as a rate or a speed or something like that. So you will be asked to interpret gradient. And I think the most important thing with interpreting gradient is to always go back to rise over run. So this is distance over time, it's kilometres over minutes, so the gradient is kilometres per minute. Does that make sense? So it's whatever those units are, rise over run, x upon y. Alrighty, I'm going to give you the example now about intersecting lines. So I want you to read on page 176 of the Beta textbook, number 9. So this one here is similar to the one that you've just been reading. So we're going to talk about this, and I'll give you the same context. So what's the context in the question? On page 176, question 9, we have time on this axis here, and we have distance here. Okay? Now, I've got a maximum distance of 6. So I'm just going to make up, just because my scale's all funny, I'm going to say distance in kilometres, and I'm going to say time in hours. Okay? So what does this mean? Distance, let's call that distance from here. Okay? So what's the purple line at 0 time? Time is 0. Where's the purple person? We're going to call these people, imaginary people. So that person is 6 kilometres away from the classroom. In 4 hours' time, they'll be at the classroom. So how fast did they go? They travelled 6 kilometres in 4 hours. Rise upon run. That's the same as 3 upon 2. So that's 1.5. So they went 1.5 kilometres per hour. Okay? Make sense? What about person number 2? What were they doing? This is my own question I'm making up. So their distance from our classroom over the next 20 hours does not change. So they are 2 kilometres away and they are staying still. So what's 2 kilometres away from this classroom? Roughly. Some cafe somewhere, the picture theatre, something like that. So this person is staying still. They are not moving. They're not going anywhere. What's the red person's start of the journey? Where do they start? That's a 3. So they start 3 kilometres away from the classroom, and it takes them 5 hours. So rise upon run, what's that, 0.6. So they went 0.6 kilometres per hour. It's like a snail, okay? You couldn't go that slow if you tried. When I run 10 kilometres in an hour, so it's kind of crazy. So this person here is going a lot faster. So notice this one is steeper, and they went faster, and this is really slow. So they started further away, and they ended up getting to the classroom quicker. What does this point here indicate? It's the intersection. Beautiful. What happened? Purple person did something to the red person. If they both were like in a linear. What's that? They passed them. That's a pass or overtaking. Okay? So this guy going a bit speedier to the classroom, this one slower to the classroom. Here, before this time here, the purple person was further away from the classroom, and after that time, the red person was. The red person was closer to the classroom, should I say. No, further away. Yeah? Here now the purple one's closer. Okay, what does the blue one do that's different? Where do they start? They start 1 kilometre away from the classroom. Yeah? And what are they doing? Are they getting close to the classroom or further away from the classroom? So just going over that, this guy and this guy, they were away from the classroom and they arrived at the classroom. This person at time 0 was where? 1 kilometre away from the classroom. And what are they doing? Going further and further away. Thank you. And at what speed are they going? If I get those 2 points. For every 1 hour, they're going 1 kilometre. Okay, so they're actually going 1 kilometre per hour. Okay, so what have we covered? We've covered trying to read what a graph is doing, and you will have to do that. Okay, reading what it means and talking about what an intersection means. So what happens there? Both these guys at 2 hours are the same distance away from the classroom. Okay? So this one's here quite a good one to play with to make sure you kind of can connect something happening with the graph. So what I'm going to do is I'm going to move his position. So he's going to the right, stopping for a second, going to the right. Then I'm going to make him go fast, stopped, and I'm going to put him back to 0 metres. Okay, now I can push play. Yeah. Oh, this is record. Oops. Oh dear, let's have a look at the charts. Okay, so I need to record. So now I'm going to move him like I was before. And so I've got a position. So this is when he goes to the left. Can you see the blue line? See what he's doing? Now he's standing still. The time goes on. Okay. And then this one here being position, this one here being velocity, and this one here being acceleration.